What's going on, data devotees? It's Jameson here. What's black and white and red all over? Probably your Shiny app code if you have no idea what you're doing. And this video is created to remedy that predicament. What we're going to talk about is not only what Shiny is, but also the logic behind Shiny that sort of makes it work. So we're going to make a non-Shiny app and show precisely how changing inputs will change outputs on a user interface. But to understand that a little bit better, let's talk about what Shiny is, and at the very end, we'll create our own Shiny app using the empty cars dataset. So Shiny is, in effect, part of this broader movement of creating interactive data products that allow data analysts, data scientists, statisticians, essentially to be able to create these interactive dashboards, reports, and so on and so forth to allow audiences to be able to explore data by selecting different inputs and filtering the data in certain ways, choosing the ways that they want to see those data. And again, part of this broader movement to really democratize the ability to create programs and applications that you really weren't able to do over a decade ago. Principally because most statisticians, most data analysts didn't really have programmer experience. So Shiny allows integration of things like JavaScript. You have the ability, again, to make even R Markdown documents. That's another example of this sort of democratization of programming and applications, again, to allow data scientists and analysts the ability to create these interactive and engaging data products for their audience. So RStudio already has a great way to be able to create Shiny. It's very much integrated into RStudio itself, and there are a lot of features that help you use Shiny. But first of all, let's start with understanding a little bit more about the logic behind Shiny. So I'm in RStudio right now. I'm going to open up a new script with Control-Shift and N. And we're going to look at the old faithful geyser data in a built-in data set called faithful. So if we look at these data, and I'm just simply going to use the function head, we can see that we have two columns or two variables. We have eruptions and we have weighting. Now, these are the number of minutes that the eruption has lasted. So we have the duration of the eruption itself from the old faithful geyser, and then the amount of time, again, in minutes, waiting in between each eruption. So those are some very long eruptions happening. And we can also see a sort of cyclicity just looking really at just the first few values where it starts longer. We've got shorter ones, and then it gets longer again and shorter, and so on and so forth. But that's for another analysis. So that's the faithful data set. And what we want to do is create a histogram that shows simply the distribution of waiting times. Again, that's the second variable, the waiting time in minutes. So in the first argument that we're going to do is faithful. Now, again, histograms only show a single variable and the distribution of that variable. And then we're going to also include breaks equal, say, 10. And we'll even include, let's see, anything else? We'll make the color dark gray. Now, this is actually a replication of the example that's used in RStudio's example of the Shiny app, and so we're just simply recreating that. So just to give credit where credit's due, and of course, we're going to make the border white. So let's see what that looks like. Again, we're just showing the distribution of all of these minutes. It's a single variable, and we're going to show it in 10 different bins or breaks. 12 different bins, I should say. So we've got these breaks on the inside, 10 different breaks, and then on each side, itself, we've got an 11 and 12. So cool. So this is the distribution of those wait times. And if we change breaks, we change the number of bins that are present in this histogram. So let's go ahead and run that instead. Okay, so we've got broader bins. We have more observations that fall within those bins. And that's because we've changed breaks. Now, let's increase the resolution substantially by increasing that to 25 breaks. And so now we can see a higher resolution of the distribution of wait times in between eruptions. So what happens if I were to say, apply to object X the value of 10? And instead of having breaks equals a hard number, we'll have it equal an object. So if I, again, change it to 10, let's run it. And sure enough, this still operates kind of dynamically. It still is fully functional. And X here is just taking on the value of 10. So this is the same thing as saying breaks equals 10. Well, what if we changed it to 25? We'll run it again. And there it is, that high resolution distribution of waiting times. And we're using this flexible value. And we're actually changing that value by inputting it here in line 3 and assigning it to this object called X. Now let's see how high we can go with this. 50, all right, so very high resolution distributions with 52-ish bins. And so that's quite a bit there. And the idea behind this is that we are the user. We're controlling, in effect, how many bins we would like to see in this histogram, and then that changes dynamically without having to interrupt this code at all. While we actually change the input here, the code itself can stay the same, and we have this object X as the parameter for the breaks argument, and that's able to work dynamically as we change the values of X. So let's see the same thing when it happens with Shiny. So we'll go into File, New File, and we'll choose a Shiny web app. We'll just call this Faithful, named after the dataset. You can choose a single file or you can choose multiple files. And what a multiple file does is essentially creates two different tabs, or you can have everything on one different tab. Now this is kind of a personal choice, that's up to you. But the idea here is that one of these is the user interface. That's what the user can see, and that's equivalent to this X takes on the value of 50. And it's not only the interface and what the user can see, but also what the user can control in terms of changing the inputs and changing the parameters in the Shiny app. And then on the back end, you have the server side. And the server side is where all that magic, all that plugging and chugging is going to happen, where the user at the user interface changes an input, and then that changes this sort of flexible programming with the server. And that's equivalent to what we've done here is we have this flexible variable X, and that's taking on these different values. So let's go ahead and hit create on that. Now we've got a bunch of code here. I'm going to use regular expressions to be able to, and don't worry about what any of that means, but this is in effect going to remove any of the annotation. Let's do replace for all. Cool. Always fun to use regular expressions or pattern matching when it comes to find and replace. So cool. Now we have a user interface. And this is essentially what RStudio creates for you as an example of your app. It already has a fully functional app for you. And I'm just going to simply clean it up so that we only have this little bit of stuff to look at and pay attention to. Awesome. I'm going to go ahead and save. And so let's see what this looks like when we run it. So in order to run your Shiny app, go ahead and just click this Run App button. We can open it in a browser if we want, but again, this is essentially what we've just done. Here is the number of bins. which is what we did with X in our Shiny intro. And sorry about that. And when we change the value of X on the input side, on the server side, that's dynamically changing the number of bins in our plot, in our histogram. So this is essentially the same thing that we made, again, only in Shiny form. So the UI is ultimately, it ultimately has one input. It has this slider input, and that has a specific ID for it. And we'll talk about that in a second, but it has a label and it says number of bins. The minimum on the slider is 1, the maximum on the slider is 50, and the starting value is 30. So let's run that app again and see what's going on here. So again, number of bins, number of bins. That's the label for this slider input. And then the minimum value is 1, which we can see here, maximum 50, and the value 30 means kind of the default starting value when you open up the app. Now, we also have the name of the plot that's output, and this is all, again, part of the user interface. So you're seeing two things here. In the sidebar layout, you're seeing these input options, and in the main panel, you are seeing these plot output options. And this plot is named distplot, and that connects us with distplot down here on the server side, or the backend. So let's talk about this code a little bit more now that we've talked about this user interface. What's going on here, and how do these inputs, in the same way, again, that we change the value for X, that would change the number of these different bins that we have here. How does this input affect what's happening on the back end or on the server side? So this slider input, again, where we control the number of bins between 1 and 50, default 30, it has a unique ID, and that's the very first argument. Input ID, and there's a capital I there, do pay attention to that. So, excuse me, this unique ID is called bins. And bins comes into play right about here. The unique ID is called with input, the extraction operator, or the $, and then the name of that unique ID. Again, bins. And so we're simply seeing right here, essentially this is that flexible or that dynamic value that changes depending on the input in the slider input widget, right? And then this produces, this assigns the number of bins, and then that becomes that flexible value inside histogram. So we produce the same thing. This is, again, responding dynamically to input bins, and that is connected to this unique ID, or this input ID for the slider input widget. Everything else is hard-coded, and none of this is flexible, and so that's all well and good. So again, that's just kind of how things work. Again, you've got this, can I say again? Again. So user interface controls the widgets. The server side does the plugging and chugging for those dynamic values that the user input changes sort of in real time. Done and done. So what if we wanted to create our own Shiny app? Well, it's never a bad idea to start off with this basic layout and use this as sort of a foundation on which the architecture of your app will be built. And so we can go ahead and kind of get rid of a bunch of these different things. We're going to want to return to this input. We can give this a new title, and since we're going to do empty cars dataset, we're going to actually do fuel efficiency measured with MPG, or miles per gallon, versus weight. Cool. I'm going to save my app right now. We're just going to call this, let's see. We'll call the plot efficiency, so we've given it its own name. And that means since we're changing the plot output on the user interface side, we need to make sure that we change the output on the server side. So this was originally called thisPlot. So this also acts like a unique ID as well. Here we're just calling it efficiency. Now, we have to choose what type of widget that we want. And actually, we're going to do this by cylinder. So instead of a slider input, I'm going to choose an input widget called radio buttons. And there are a bunch of these different input options and widgets that you can use that you can find easily online. You just have to do a quick search of with your search engine of choice for shiny input widgets, and then that will give you likely some sort of a page with a list of all these different options for widgets that you can choose. What do radio buttons do? Well, it's essentially a forced choice. With radio buttons, you have to choose one category or another category, but you cannot choose more than one category, and that would be a select input function. But instead, we're going to use, again, radio buttons function. And so before we get into this, let's go ahead and make our visualization. And we're going to do, let's see, a scatter plot would be nice. And so we're simply going to do plot x equals, let's see, what are we going to call? Let's call this subcars, and that'll come into play next. But we're going to be renaming our data set according to our input. Our data set will become filtered, and we'll call it subcars. But we'll get to that in a second. So we'll do subcars MPG on the x-axis, and on the y-axis we'll do subcars weight. So cool. Subcars hasn't been created yet, and that's because we've got to create some input options here. So with radio buttons, we can use tab, and then the autocomplete will show us our very first input that we can, our very first argument, which is the input ID. Now this input ID is what ties this widget to whatever's happening in this render plot function down on the server side. So here we'll just call it cylinders. It's nice to try not to have your input ID the same name as the variable you're using. It's good to have those differentiated, and it's easier for you to be able to decipher your code and understand what's going on. So we'll do label equals number of cylinders, and that's going to be in quotations, and that's essentially labeling the widget. And the next argument is choices. So with choices, we simply provide all of the different options that the user can select. So we're going to choose 4, 6, and 8 because there are 4, 6, and 8 cylinder engines in the data set. And lastly, selected is essentially the default choice that you basically want as soon as you want this to be selected as soon as the app is opened up. So you can set default choices. You don't always have to do this, but it's just going to make coding easier for us. Otherwise, we have to get a little bit more sophisticated with this. So again, I've taken this new widget. I've decided against the original input widget, and I've chosen radio buttons, which is for forced choice. We've given it a unique ID. We've labeled it number of cylinders. We've listed the choices, and then we've created a default choice. So we've also given a unique ID to the plot that's going to be produced. And this is all happening on the user interface side. Now, what's happening on the server side? Well, we've already created our plot, but what's going on with this? Well, that's because we want to, in effect, create a subset of empty cars, and we're going to put that into subcars, and that then becomes our dynamic data set. So that data set will change depending on whether we choose a 4, a 6, or an 8-cylinder engine. So how do we do that? Well, we start with empty cars. We're going to go into indexing. So in other words, these are the brackets. Recall that on the left side of the comma, in brackets indicates which row, and on the right side indicates which columns. And as we saw earlier in earlier videos, we are going to use a logical or a conditional statement. And in this case, it's going to be empty cars cylinder is exactly equal to what? Well, we would say exactly equal to 6, but that's hard-coded, right? So this is only going to return a subset of the data where cylinders is exactly equal to 6. But that's, again, hard-coded. We want something that 8 is also hard-coded. Instead, we want something that represents a value that we can change. And that's where this input ID comes in. So what we do is, in order to call an input ID, we always type input, we use the extraction operator, and then we use the name of that unique input ID. So in this case, it's going to be empty cars datasets variable cylinders is exactly equal to whatever unique input takes the place of this input ID. And that can be 4, 6, or 8. So cylinders is exactly equal to 4, 6, or 8. If it's true, because it's in the brackets and indicates the row positions that we want from empty cars, those trues, or those that have exactly the number of cylinders that we've selected, becomes subset with this smaller data set, and then we plot that subset. So I'm going to save it. Let's see if this works. Oh! Happens to the best of us, and I'm not even the best of us. Cool. Oh, shoot. And you don't have to hit run app each time, but I'm just trying to avoid showing any extraneous content, so I'm just reloading that. So we've got number of cylinders here, and these are our choices that we've allowed, 4, 6, or 8. By default, we've chosen 6. Our input ID is cylinders, and we've labeled this input widget, or the radio buttons, number of cylinders. Now, this, when we select it, will change the unique input ID for cylinders to either be 4, 6, or 8. And then that affects, in our server side, how empty cars becomes filtered. Empty cars becomes filtered into a new object called subcars, which is a subset or a smaller data set from empty cars. And then we plot with that subset using miles per gallon and weight. And there we have it. It's perfectly dynamic. And again, this all goes back to simply making a histogram or a plot or some sort of output where you have this dynamic value, and we assign through user inputs new values for that dynamic object. It's the same thing that's happening here with user interface and with server. So cool. That's Shiny in a nutshell. Hopefully you found this video helpful. And this is really, again, the logic and how you can create your own Shiny apps. Do recall that if you have any other sort of dynamic processing going on, that can't happen outside of any sort of render functions. And that's what's going on with this curly bracket and that opening and closing parentheses there. So do keep in mind, anything dynamic, anything that uses input cylinders, that has to happen within render plot. And you can also do, obviously you have to load the Shiny library with the library function. But also keep in mind that you can do other pre-processing in your Shiny app too. So we can make other changes to empty cars or whatever data we're using up here at the top before we even start the user interface or the server options there. So cool. Again, hope this was helpful. Shiny is an amazing tool, again, for data scientists and analysts and all manner of folks who don't really have the programming acumen to create interactive ways to engage, allow your audiences to engage with your data in creative and fun ways. But Shiny really is part of that broader movement to allow you to create awesome data products. And once you understand it, it is relatively simple to kind of wrap your head around and use rather fluently. And what's more, you can create tons of inputs, create tons of outputs beyond just histograms and scatter plots and things like that. And things can get really, really interesting. This is really just the tip of the iceberg.